Wednesday morning to you. Hope you're doing well. Hope you're ready to go through your Aspire review, and I hope that you did the best that you could do. All right, you ready? Here we go. Number one, we wanted to name this figure. Okay, we are out of the quadrilaterals. Did you notice? Not 4 sides today. There are 5. So what do you call a 5-sided figure? Do you remember? Starts with a P. It is a pentagon. This is a pentagon. 5-sided figure is a pentagon. All right, and this question asked, how many lines of symmetry does this pentagon have? How many lines of symmetry does this pentagon have? Well, can you take your paper and rotate this pentagon? Does it look the same as you turn it? It does. How many ways can you turn this pentagon that it looks the same? Five different ways. This has 5 lines of symmetry. It has 5. Every time I turn it, and you get this angle at the top, you can draw a line straight down through the angle and through your bottom side, okay? And you can do that 5 different times as you turn your paper. You can go ahead and do it right now if you'd like. If you want to try it, okay? Just pause the video and go ahead and draw your lines. Every time you turn it and that angle comes up, so if I turn this again, this line will be up here and I would be able to go through the angle and then straight through that side. Through the angle and straight through that side. Through the angle and straight through the side. Through the angle and straight through the side. It's going to have 5 lines of symmetry. All right, in a pentagon. 5 sides, pentagon. Say it, pentagon. Say it, pentagon. Say it. There you go, pentagon. All right, number 2. Ernie has some books. Bert has 12 books. Bert has 3 times as many books as Ernie. How many books does Ernie have? Okay, when we're talking about 2 people or 2 things or 2 groups, we label Ernie, Bert. All right, it says Bernie has some books. Some. Does it tell us how many? All right, we want to be able to hold that place. We want to be able to put something in that place for that number. We don't know what it is. So a lot of times in math, what you find is that you'll use a letter, okay? And oftentimes what I'm going to use this year is I'm going to use the letter N. Right? Just because. You got to be careful about letters that you use because you don't want to use something like X. Why? Because it looks like a multiplication sign. You don't want to use a T. Why? It looks like an addition sign. So I like to use a letter like N, okay? So, Ernie, and the reason I'm using that, Ernie has some books. Now, you can use a picture. You know, Ernie has flower. You can put a flower. You can put a chicken head, snowman, elephant butt, whatever. But oftentimes the letter works better, all right? So, he has N books. We don't know how many. Bert has 12 books. And then it tells us that Bert has 3 times as many as Ernie. He has Ernie's amount times 3. Well, that helps because now I can look at this and say, all right, N times 3 equals 12. Well, I know what that is. What times 3 equals 12? 4. Ernie must have 4 books. Ernie must have 4 because if he's got 4 and Bert has 3 times that amount, 3 times 4 is 12. So Ernie would have 4. Okay? Now, let's say you didn't know. Let's say you didn't know. For some reason, you didn't know your multiplication. You said, oh, and so this is what you have. He's got 3 times. Well, what can you do? Make 3 circles. And start counting your way to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many are in each one? 4. So Ernie must have 4. Okay? Now, I'd rather you learn your multiplication rather than making a picture. But sometimes you got to do what you got to do. So if you got to make a picture for right now, fine. But learn those multiplication facts. All right. Number 3. Put a box around all of the prime numbers. Put a ring around all the composite numbers. Prime numbers, how many factors? We talked about this for the last 2 days. Prime numbers, 2 factors, 1 in themselves, okay? 1 in themselves. If chicken head is a prime number, 1 times chicken head, right? That's the only factors it has, all right? Composite means it has more than, okay? More than 2 factors, all right? 2, prime or composite? Prime, should have had a box, okay? 3, prime or composite? Prime, 1 times 3. 4, prime or composite? Composite, 1, 2, and 4. Ring around it. 5, box or ring? Prime or composite? 5 is prime, gets a box. 6, prime or composite? Composite, 1 times 6, 2 times 3, gets a ring. 7, prime or composite? Prime gets a box. 8, prime or composite? It's composite. 1 times 2, or 1 times 8, 2 times 4, it gets a ring. 9, prime or composite? Composite. 1 times 9, 3 times 3, gets a ring. 10, prime or composite? Composite. 2 times 5, 1 times 10, gets a ring. 11. 11 only has 1 times 11, it is prime, it gets a box. So we should have had boxes around 2, 3, 5, 7, and 11. We should have had rings around 4, 6, 8, 9, and 10. All right, remember that all your even numbers after 2 are always going to be what kind? Composite, because you're always going to be able to divide by 2. Number 4, 2 and 1/4. 2 and 1/4. All right, that's what you were to draw a picture that showed 2 and 1/4. Okay, so how many objects would you have to draw if you were going to do 2 and 1/4? You'd have to draw 3, 2 whole ones, and then the fraction in the last one. Each of your objects should be in how many parts? Which of these numbers tells you how many parts it should be in? Your denominator, right here, that should have told you, but all of your figures should have been in fourths. Now, you could have made squares, could have made rectangles, could have made circles, okay? Whatever's easiest for you. Rectangles and squares are going to probably be easier than circles depending on your denominator. So I would probably go with a rectangle or a circle, all right? Or a rectangle or a square, rather. All right, so I'm going to make rectangles, and I'm going to make 3 of them because I've got 2 whole ones and then 1/4 that's not whole. Now I divide them both into fourths. Fourths are easy. You simply do a cross like that, and it makes it into fourths. All right, if I want 2 and 1/4, how many do I shade here? All of it. Now, you don't have to color it in. A couple diagonal lines is shading. How many here? All of it. That's 2. How many over there? That's the 1/4. 1. There is 2 and 1/4. Now, let's look at it as an improper fraction. What would my improper fraction be? Remember why it's improper? Big number in the numerator, small number in the denominator. Okay? What's my denominator going to be? Still 4. My denominator doesn't change. If it's 3 over here, it's 3 over there. If it's 8 over here, it's 8 over there. It's 4 here, it's 4 over there. All right. Now, how many fourths do we have? Well, how many fourths here? 1, 2, 3, 4. How many there? 5, 6, 7, 8. There's 4 more here. How many there? 9. That would be 9/4. 9/4. Okay, that was your improper fraction for your picture. All right, last one, perimeter and area. I didn't put any squares today. I just gave you numbers today. I took the squares away because I've been telling you how we could look at that. Okay, perimeter, we're still going to do the same thing. We're going to start in the corner. We're going to walk our way around. Okay, 5 here, 4 there. This side will also be 5. And that side will also be 4. Opposite sides of a rectangle are the same. So, 5 and 4 is 9. 5 and 4 is 9. 9 and 9 is 18. Did you have to add it that way, the way I did it? No. 5 and 5 is 10. 4 and 4 is 8, but you're still going to get 18. Addition has a commutative property. You can set up your numbers however you'd like to do that. All right. So the perimeter is 18 units because it's not labeled, so we're going to put the word units. Now we're going to do the area. How do we figure out the inside? Inside we count the squares. Well, this is telling me, the 5 is telling me I'm going to have 5 columns. The 4 is telling me I'm going to have 4 rows. So what I'm going to end up with is 4 rows of 5. In other words, I'm going to have 5 blocks and I'm going to have it 4 times. So let's use multiplication today instead of drawing squares. Okay? What is 4 times 5? 4 times 5 is 20. So this would have an area of 20 square units. Now, do you want to go ahead and put them back so we can see? Could you have put the squares in there? Could you do it? Sure. I'm trying to make less work for you. The more you know your multiplication facts, the less work you have to do as far as writing things. All right? So if I made the 5 columns, 1, 2, 3, 4, and 5, and I made the 4 rows, 1, 2, 3, and 4. I've got 4 rows of 5. Here's 5, 10, 15, 20. And that's just what we had in the beginning. All right, if you're struggling with that, make an email, shoot it to me. All right, real quick. I haven't done these, and I meant to, for Monday and Tuesday. All right? Make the greatest number you can make. 875, smallest number you can make. 578. Rearrange these numbers, make the greatest number. Rearrange the digits. Good, say it. 9,743. Make the smallest number. 3,479. What do? Good, you add. Say out the same out. What do? You subtract for the difference. Okay, what's the fraction? 4/8. Good, look at it differently. Look at it as columns. Give me another fraction for it. 2/4. Good, 2/4. What are the 5 numbers in the ones place to make a number odd? Do you remember? 1, 3, 5, 7, 9. Good. What are the 5 numbers in the ones place to make a number even? 2, 4, 6, 8, and be careful, 0, because 10 can't fit in the ones place. 2, 4, 6, 8, and 0 make a number even. All right? Name the figure. It's triangle. What kind? All three sides are the same. They're equal. It's an equilateral triangle. Good. How many lines of symmetry? 3, because I can turn it this way, that way, and it all looks the same. I'm going to have 3 lines of symmetry. What kind of triangle? They're all different. It's a, remember? Scalene. I heard it. Good. Scalene. Nice job. How many lines of symmetry on a scalene triangle? None. What kind of triangle? Sounds like this. An isosceles triangle. Good. It has 2 equal sides. Isosceles. How many lines of symmetry? 1 down the middle. Name the shape. Rectangle. Name the shape. Parallelogram. Sometimes kids want to tell you it's also a rhombus if I turn it that way, so you can see that the sides are equal. Okay? Parallelogram. Name it. Square. Name it. Trapezoid. Good. 1 pair of parallel sides on the trapezoid. Name it. Quadrilateral. All it is it's a 4-sided figure, nothing else. Okay? Now, I'm going to throw some things in here that we may not have talked about, but you know these things. These 2 lines go in the same direction. They're what kind of lines? Parallel. Okay? That's what parallel goes in the same direction. Okay? When lines intersect and they make an angle, okay? This angle is big and wide. We talked about a right angle. If it gets bigger than a right angle, it's called an obtuse angle. Say obtuse. Say it again, obtuse. This is an obtuse angle. If it's smaller than a right angle, if it's less than that square, it's called an acute angle. And the way I always remember that, think about little things. People always think they're cute. Oh, look, how cute little baby. Oh, it's so cute. So this little angle is cute. It's a cute little angle. It's acute. I know I'm weird. All right, this one. There's that right angle. Good, right angle. These kind of lines, we said parallel go in the same direction. Lines that cross and make right angles, they're intersecting, but they're a special kind. These are called perpendicular lines. Perpendicular. Say perpendicular. Perpendicular lines. We'll talk more about these later. All right, next. How many ounces in a pound? 16. Good. Feet in a mile. Feet in a mile. 5,280. Nicely done. 5,280. Inches in a foot. Show me an inch. Show me a foot. How many inches in a foot? 12. Good. Show me a foot. Show me a yard. What? How many feet in a yard? 3. 1, 2, 3 feet a yard. 1, 2, 3 feet a yard. Okay, foot and yard dance. Pounds in a ton. Tons are heavy. How many pounds in a ton? 2,000. Nicely done. Give me the mixed number. Look at it. Give me the mixed number. How many whole things? 3. What's my fraction? 3/4. 3 3/4. Give me the improper fraction. What's going to be my denominator? 4. How many? 4, 8, 12, 13, 14, 15 fourths. All right, gang. You're working hard. I'm proud of you. Your teacher's telling me you're doing a great job of these at home. So keep it up. All right? Look forward to seeing you again. Bye.